what is the locking of the page? Okay, locking of the page is nothing but in RAM. Actually, for OS is assigned certain memory to SQL. This is the amount of memory assigned by the OS to the SQL. In SQL, it arranges some memory for buffer pool. This is SQL server memory. In that memory, SQL makes some part of the memory as a cache memory. Okay, and now we discussing locking of the pages. Why we need scenario locking of the pages? Okay, the lock pages in memory policy in SQL Server prevents the Windows OS from paging out. Okay, the SQL Server memory, especially the buffer pool to the page file. This ensures that SQL Server keeps its memory resident in physical RAM for optimal performance. Okay, what problem it is solving that by default Windows can swap out SQL memory to disk under memory pressure. That means OS is assigned certain amount of memory to the SQL, then SQL will to this memory, OS will decrease or swap this memory to hard disk, file disk. That means again SQL has a power to erase or swap almost some amount of memory. If that is happening, then SQL need its certain pages always in RAM in order to start the engine. Like in our app settings, we need to maintain in RAM. Based on the settings only our application will functioning like that. Minimum some pages need to kept in RAM in order to perform SQL process, SQL in order to do its operation. That's why SQL server make that certain pages as a pinned pages. That means locked pages. No one OS itself cannot able to evict that pages. Okay. Now this paging to disk cause severe performance degradation. That means SQL server might seem to freeze while data is being paged back in, especially harmful for systems with heavy workload. Okay, what are the critical pages it must and should available in RAM? Certain pages are there, like I will discuss later. Each page functionality, but it must keep in RAM. Always boot page will be there. This boot page always available. What is the purpose of boot page? I will discuss. Mostly it contains the metadata of the database. What is the database name, which version it is using, how many tables are there, minimum this metadata. And next is file header page. It store the how many files are there, each file, what are the header configuration, means settings of that file, and metadata of that file it is stored. For each table, suppose we have like that multiple pages are there, each page metadata it is stored in file header page. And in the same manner it stores some how many pages are free, gam pages, sjam pages, index allocation pages. I will discuss elaborately related to respective functionality of each page. Okay, it maintain must and suit some pages. Let us take as a table, which is a cluster table. So cluster table contain root B tree. Okay, in for that B tree there are bottom contain marginal data, leaf node contain original data, but parent and intermediate just contain the reference. It is very low space memory. So these pages must be stored in RAM only. For query processing engine, it need to know what are the pages required. So to fetch to DML operation like update delete, it need to know what the page. Okay, to get to know the what the page, again it need to go to the hard disk. That's why to avoid that we have to put certain index pages. Before index pages we have one page is there, static IO page. It mustn't show statistics IO page, mustn't should available in RAM only. Otherwise for each query, what is the to generate the execution plan, it need to go to the hard disk and search the statics page, retrieve the statics page. Okay, and based on the statics page it generates the what is the execution plan. So it takes large amount of time. That's why minimum we need to put statistics IO page in RAM only. We cannot edit that page. It is very small page. We have to that's why some pages need to be pinned. Okay, we have to avoid the eviction. Okay, that is the thing. Okay, anything miss? Okay. Okay. Pinned pages cannot be evicted. Used for frequently accessed index, root pages of the B tree, hot lookup tables, statistics table. So what are the benefit is fast access to locked data, reduce this IO, better control for critical workload. Then problems are uses more RAM, maybe chances of uses more RAM, can starve other process of the respective OS, risk of memory overcommitment if not managed. Okay, having to perform this IO on each read or write is impractical. Subsequent read may request the same page, just as subsequent write may modify the same page. Okay, since B tree gets narrow toward the top, higher level nodes, ones that are closest to the root, are hit for most of the read. For each read, higher level node must be hit. Okay, this higher level node must be placed. Split and merge also eventually propagate to the higher level nodes only. This means there is always at least a part of the tree that can be significantly benefit from being cached. The point it is saying that B tree get narrowed toward the top. Higher level node, ones that are close to the root, are hit for most of the read. Next, not only the read, some DML updation and delete happen that makes split of the certain nodes at the bottom or merge of the certain node at the bottom or intermediate. Split and merge also eventually propagate to the higher level node. This means there is always at least a part of a tree that can significantly benefit from being cached. We can lock pages that have high probability of being used in the nearest time. Locking pages in the cache is nothing but pinning. Pinned pages are kept in memory for longer time, which help to reduce the number of disk access and improve the performance. Since each lower B tree node level are exponentially more nodes than the higher, and higher level nodes are represent just a small fraction of the tree, so this part of the tree can be reside in memory permanently, and other parts can be paged in on demand based on the demand. This means that in order to perform a query, we won't have to make disk as access as discussed in B tree look, but only hit the disk for the lower level node for which pages are not cached. Okay, only hit the disk for the lower level node for which pages are not cached. Operations which are performed against subtree may result in structural changes. Structural changes is nothing but some nodes are deleted, sub nodes are updated, that make a transformation of the node, means splitting of the node, moving the data from bottom to top node, like that. Multiple delete operation causing merge followed by writes causing split, or vice versa. For structural changes that propagate from different subtree, structural changes occur close to each other time in node. Okay, these operation can be buffered together. Okay, this operation like split, merge, update, delete operation can be buffered together by applying changes only in memory, which can reduce the number of disk write and the operation cost. Okay, okay, one thing I explain here, whatever the point I can discuss. Most database, whatever bit, especially those are B tree and LSM trees, uses tree structure for indexing and organizing data. When you are doing multiple operations like insert and delete on a tree structure, some of these operations can conflict or trigger structural change. What is structural change is nothing but node becomes split by inserting something, node become merge, two nodes are merged by deleting some data in the node. Okay, rebalancing, that is caused by cascading changes of the tree. Okay, for example, let's say you perform delete A causes a merge, insert B causes a split, update C modify a pages that are already involved in a split and merge. Each of these may require changing the structure of node, moving keys between nodes, writing updated nodes to the disk. Okay, solution is buffer and apply in memory. Instead of writing each change immediately to the disk, the database collect buffer changes in memory. It allow multiple operations to accumulate, then it apply them in bulk. Whatever node split, node change, deletion operation, that means merge, those are change instead of individual one, then it apply them in bulk. This is called amortizing the cost, doing one right instead of many, doing one right instead of many. Okay.